Hello, hello, hello. So we're going back to the definition of linear dependence. So we're going to have to, because we're given Rn, so we can't use anything special about Rn, R3, R2. It's not one of those, or it could be, but we're not specifying. So we're going to have to go back to the definition of linear dependence to solve these examples. So pause and copy if you haven't done so already. So the first one. So we're given a set with two vectors. We're told it's dependent. What does that mean about this slightly larger set? Well, it's necessarily dependent because, well, I can take the dependence that I have for this set. That will give me a non-trivial dependence relation involving these two vectors. So let's write this down carefully. Okay, UV, this set, is dependent. Therefore, AU plus BV is equal to 0 for two scalars A and B, not both 0. And I can immediately get a dependence relation for this set here, just by inserting another term right there. Let's go AU plus BV plus a little math trick plus 0W is still equal to 0. Okay, this 0W is the 0 vector. And this right here is a non-trivial dependence relation for the vectors U, V, and W. So U, V, W, by definition, is dependent. Okay, so I had to use the definition of dependence. Okay, a collection of vectors is dependent if there exists a non-trivial dependence relation. So just working with that definition. Okay, next one. Okay, why is this set dependent? Well, again, I'm going to have to go back to the definition. Definition says that this set is dependent if I can find a non-trivial dependence relation for these three vectors. So this just requires a bit of, shall we say, noticing awareness. If I add these three together, what happens? U cancels with U, V cancels with V, W minus W cancels with plus W. So in math speak, we say, notice that 1 times the first vector plus 1 times the second vector, that's a W, plus 1 times the third vector equals 0. So this, what I've written here, is a non-trivial dependence relation because the coefficients are not all 0. So which is a non-trivial dependence relation Therefore, the aforementioned set, don't feel like writing it all down again, is dependent.